Welcome to the online lectures for software engineering. In today's class, we'll be discussing the topic developing use cases. Now, within the previous class, within eliciting requirements, we have studied a topic user scenarios. Within user scenarios, I have given an example for use case. Now, let's recall what is a use case diagram. Now, a use case diagram, it is basically a behavioral diagram. That is, it is going to show you the behavior of a particular system. Now, when it shows the behavior of a particular system, it is also representing how the user is going to interact with the system. Now, how the user is interacting with the system, this also shows what is the relationship with the different use cases in which the user is involved. So within this topic, we are going to study how a use case diagram is developed and how many use case diagrams are appropriate for representing an entire system. Now, as I've told you, it depicts the behavior of the system. What type of behavior is depicted? It depicts the dynamic behavior of the system. Now, what do you mean by the dynamic behavior? The dynamic behavior, it means that when the system is running. Dynamic means when the system is running. That is, what is the behavior of the system when you're executing a specific task. Now, this use case diagrams, within the previous class, we have identified the different elements within the use case diagram. You have identified the different actors, the system boundary, and the relationships. Now, actors are stickman. This can be primary or secondary actors. System boundary, it is going to tell you the difference between the external and the internal environment. Environment with whether it is internal or external. You get to know that. Then relationships. Relationship means how you're going to connect. What is the connection between the two different elements? Within the previous class, we have seen the simple relationship, that is association, that is represented by the straight line. Within labs, we will be discussing the different in detail, the different relationships. Now, for now, this is a use case diagram. You're going to have actors, system boundary, relationship. Actor is represented by a stickman. System boundary is represented by a rectangle. And use cases, I did not mention the use case. The use case is represented by an oval, and relationships are the connections. You can say the lines. Now, if you represent a single use case means you're drawing one diagram only. When you're drawing one use case diagram, this one use case diagram is going to capture the functionality of a system. That is, what are the different functions within a system that can be identified when you use one use case diagram. Whereas when you're modeling the entire system, when you need to model the entire system, that is, you need to know what is the behavior of the entire system, then you're going to use multiple use case diagrams. For this case, you require the representation or the drawing of multiple use case diagrams. Now, coming on to the purpose of use case diagram, why we are designing the use case diagram. Now, the use case diagram, they are helpful to gather the requirements. Now, gathering the requirements means what are the different functionalities, features that you want within a particular system. Now, when you draw a use case diagram, you identify the different actors. That is, an actor, what job he's going to perform, that is going to be the use case or the functionality. So when you are drawing each and every instance, you get to know the different requirements that are there within the system. Then you also get to know the outside view of the system. Now, the outside view of the system, this outside view of the system, as we are using the system boundary, by that you get to know what is the outside view. Within the inside view, you're going to have different use cases. Within this use case, this means the internal behavior. External behavior means externally you're going to have the actor. What are the different jobs that this use case is going to perform, that is going to be identified. So you get to know the outside view of the system. Then you also get to know that you can identify the internal and external factors that affect the system or that are affecting the system. And then you know how the interactions are taking place. That is, what actor has got what task to perform. There can be another actor in here. This actor may make use of the third use case. So you get to know what are the different interactions with all the requirements. So this is an overview of use case diagram. Now, there are different steps when you're drawing the use case diagram. Coming on to the first step. The first step in writing a use case is to define the set of actors. Now, what are the different actors that are involved within a story? Now, this use case diagram, you can say these are basically scenarios. That is what is happening. You're narrating like a particular story. These are the different tasks that are going to be performed by a particular actor. This is the relationship. So it is a story. Within the story, you're going to identify the different actors that are involved within the story. Then the second step is a typical user may play a number of different roles. That is, if suppose you're having one actor. Now this one particular actor, he might play different roles at different times. We're going to see an example of the different roles. When you're using the system, one actor, he can play different roles at a particular time. Now this actor represent a class of external entities. As I told you, within the use case diagram, you're going to have a system boundary. Outside the use system boundary, you're going to have this actor that is represented by the system by a stick man. So this is an external entity. Actor is an external entity. Whereas all the use cases, this are going to be your internal entities. The next point is, because requirement elicitation is an evolutionary process. Now, what is requirement elicitation? Elicitation means requirement gathering. That is, when you're gathering requirements, you're not going to capture all the requirements in one step. Within one go, you cannot capture all the requirements. So to gather all the requirements, you're going to gather it within a stepwise fashion. That is, within one phase, you might discover a few requirements. Within the second, you can uncover a few set of more requirements or sub requirements or sub functionalities. So these different use cases, they can also not be defined at first level. These all actors are going to be identified during the different iterations. So not all actors are identified during the first iteration. Within the second, third iterations, you can identify the different actors that are involved. Now, as I told you, there are two types of actors. Within the actors, you've got the primary actors and you've got the secondary actors. Now, what are these primary and secondary actors? Primary actor interacts to achieve a required system function. That is, this is the main actor. You can say this is the main person that is initiating a specific task. So this actor is going to interact to achieve the required system function and derive the intended benefit from the system. They work directly and frequently with the software. So primary actors, they work directly with the software. The second is secondary actors. Secondary actors support the system so that primary actors can do their work. Now, if we take an example, You have a system boundary. So you have this actor. This is a primary actor. Now suppose this is the customer. Customer is your primary actor. Now this is, suppose a person wants to open an account. So this is the bank. Now we're going to have a secondary actor, bank, or you can say the ATM. We'll name the secondary actor as bank. Now this customer, if suppose he wants to open an account within the bank. When he wants to open an account, there is a relationship between the customer and opening an account. That is, he is directly interacting with the system. The word here, directly interacting with the system. Now to open the account, the customer cannot itself open the account. He needs the authentication from the bank, where he needs to submit specific documents, then his bank is going to be opened. So this all documents, they are going to be verified by the bank. So bank is your secondary actor. So primary actor, he's directly interacting with the system. There's direct interaction in here. Whereas to complete this task, he needs authentication from the bank to open the account. Now if suppose the customer wants to transfer funds, then again there is going to be the relationship between the customer and directly use case transferring the funds. And thus transferring the funds, you can directly transfer the funds, or you need to get the bank number that you're giving as address, that is your IFSC code, the person that you're transferring the balance to. You need authentication from the bank, and this bank is also as a primary actor, because as you're transferring the funds, the deduction of amount, this needs to be updated within your bank statement. So that is why the bank is going to make those changes. That is why again the transferring of funds, again there is a association with the bank. So this is the difference between the primary actor, this is your primary actor, and this is your secondary actor. Now the number of questions that should be answered by a use case, that is whenever you're designing a use case diagram, there are a few questions that need to be answered. Who is the primary actor and the secondary actor? You need to get to know. That is, who is the main person that is interacting and who is the helping person that is going to help you to complete the task. What are the actors' goals? Now, when you identify the primary and secondary actor, you need to know what goal is achieved by the primary actor and the secondary actor, whether they are achieving the same goal or they've got different tasks. Then what precondition should exist before the story begins? Precondition means if suppose there are passwords, if you're making a transaction from the ATM, you need to enter the PIN. So that is a precondition. If your PIN is correct, then only you'll be able to make the transaction. Then what main tasks or functions are performed by the actor? You need to get to know, when you're identifying the primary and secondary actor, you need to have a list of all tasks that is going to happen. Within the previous example, we've seen that the customer is doing two things: opening the account and is transferring the funds. So you're going to have the list of tasks that are going to be performed. Now, one use case, one actor, he can either perform one task or he can perform more than one task. So if the actor has to perform more than one task, you need to have list of all the tasks so that you can implement all of those tasks within the use case. What exceptions might be considered as the story is described? You need to have different exceptions also when you're designing the use case diagram. That is, suppose the PIN is incorrect, what is going to happen? If the PIN is incorrect for the second or third attempt, then the bank is going, the ATM is going to suck in the card. So that is an exception. The next is what variations in the actor interactions are possible. That is what variation in how are the different use cases that are changing within the for one particular actor. Now this is based upon the different tasks that are performed by the user. The next is what system information will the actor acquire, produce, or change. Now if suppose within the bank example, the secondary actor was the bank. So now this bank, if you're transferring the funds, so in here it is going to change your account balance. It is going to reflect the change in balance as you've transferred the funds. If you've received funds, then again your account balance is going to be updated. So if there is any information that is going to be changed by the actor, that also is going to be identified. It is going to change, produce, or acquire. That is going to happen. Will the actor have to inform the system about changes in the external environment? Now if there are any changes within the external environment, whether that needs to be informed, that needs to be identified. That is whether the actor is responsible for reporting any changes within the external environment. Whether that is the job of the actor, that is going to be identified. Whether the actor is performing. Now if within that previous example, you've got the customer that is opening the account, you've got the bank that is going to update you the account. Now if suppose you've got another use case, another actor, this can be a technician. So now the job of the technician is going to add money within the ATM or to check any technical faults. So if there are any changes within the environment of the software, whether that is the task of the customer, whether that is the job of the actor, that needs to be identified. So that is the job of the technician here. So the actor needs to inform the system about changes within the external environment. What factors are affecting, that need to be updated by the technician. Then the next is what information does the actor desire from the system? Now within this, if the customer wants to check balance, that is also one use case. So what information does the actor desire? That is also going to happen. Whether he wants to check the balance, whether he wants to transfer the funds, each and everything is going to be identified. Then does the actor wish to be informed about unexpected changes? Do you want any updations within the software? Do you want those reports? Do you want emails? Do you want to be subscribed to different forums? That is going to be identified. Now this all need to be identified, because each and everything, when you are depicting each and every list as a requirement within the software as a diagram, then it becomes more clear for the software engineer to embed all of those features within the software. So you need to identify all these points while you're developing the use case. Now we'll take an example. Now this is a safe home control panel. That is a security mechanism that is implemented in homes so that you get so that you have maximum security. That is, no one is going to enter your house without the entering the valid key. Whether then it is going to play an alarm, and you can have different sensors also embedded. You can have different sensors. You can have like door sensors. When a door is open, you can have window sensors. Different sensors you can embed and attach with the safe home control panel. Now within the safe home control panel, you're going to have a homeowner. Now this homeowner is going to make use of this control panel, and we are going to see how the use case diagram is going to be developed for activating the system, and the basic template that is going to be followed whenever you're designing the use case. So within this safe home control panel, you're going to have four actors. The first one is going to be the homeowner. Now this homeowner is basically your user. The homeowner is going to be the user. The next is the setup manager. Now this setup manager, he is the same person as your homeowner, but playing a different role. As if within the previous slide, I've told you that I'll show you an example for one actor playing different roles. So this is the same actor playing two different roles. He's the homeowner and he's also the setup manager. The same person as your homeowner, but he's playing a different role here. The next one is sensors. What are sensors? Sensors are different devices that are attached to the system. Like within the previous slide, I've told you, you can have door sensors, window sensors, perimeter sensors. These are the different sensors that you're attaching with the control panel. The next is monitoring and response subsystem. Now, this is the central station that monitors the safe home system. The central station that monitors the safe home security function. So 4 actors. Now, what are the different steps that are going to happen when the homeowner is accessing the safe home security system? The first is the homeowner actor, that is the first actor. He is going to interact with the home security function in a number of different ways. These are the different ways in which the homeowner is going to interact with the system. Ways using either the alarm, control panel, or the PC. That is, he can directly make changes within the control panel, that is this particular device, by making use of this particular device, or he can access this by making use of his computer or laptop. So the first step that is going to happen is here, the homeowner, he's going to observe the safe home control panel. Now, why he's going to observe? The first task is that he's going to approach this control panel and he's going to check whether the system is ready or it is not ready. Now, what is not ready first? Now, within the safe home security system, I've told you there are different sensors. Now, if suppose I'm using a door sensors, now when I'm using this door sensor, it means that when I want to activate the system, the door need to be closed. So when the door is opened without the homeowner, without entering the safe pin, then it is going to send a message to the homeowner or even to the police department that an intruder has come into the home. Now, if suppose this door is not closed, it means the system is not ready. The homeowner, he needs to go and close the door or windows, then the system is going to be ready. Now, when the system is ready, there is going to be a light that will be displayed as ready. And here you've got armed power. So in here, when the system is armed, it is going to tell you that the system is ready. The next one is when you have completely closed all the windows, doors, the system is going to be ready. Now the homeowner, he is going to make use of the keypad that is present on the system to enter the password to allow all other interaction. That is, if he wants to activate a few sensors, he can do that. So he's going to check the password. Now, when he's entering the password, what is going to happen in here? When he's entering the password, this password is going to be checked with the one that is stored within your safe home security function. It is going to compare your password with the one that is saved. Now, if the password that you have entered, if it is matching the one that is saved within this safe home security function, then you're going to be able to make any other interactions. If suppose you enter an incorrect password, then it is going to beep once or reset itself. So that is the second step. The next one is inquires about the status of the security zone. Now, status of security zone means in here you can have the stay function activated or you can have the away function activated. Now, within the different sensors, you can have different sensors like the perimeter sensors. The perimeter sensors means if you've got the backyard or the lawn, within the lawn also you're going to have sensors. If anyone tries to intrude, that is going to be displayed, an alarm is going to beep. Now, when you have activated the stay function means all the motion detecting sensors. That is, if any person is moving within this house, that is also going to be detected. All stay means this motion sensors, they are going to be deactivated. If you're selecting away means all these motion sensors, they will be activated. That is, any motion within the area, within the home and outside the home, each of them will be activated. Whereas if you're staying within the home, then you're going to deactivate the motion sensors within the home, because you're going to move around the home and you do not want an alarm to play whenever you're moving around the home. So that is the second point. You're going to inquire about the status of the security zone, whether you're staying in home or whether you're going away. The next is inquires about the status of the sensors. Now, the status of the sensors in here, when you've activated the sensors, then a red alarm light will be displayed. So if you've activated stay or away, whether it is armed or not, the system is activated. Within this alarm light, you're going to have this red light that will be displayed. That means that the system, all the sensors are activated at this particular point. Then the next task is press the panic button in an emergency. Now, there is also an emergency button within the system. Within an emergency, if suppose there is an emergency, any person has intruded within your home, then you're going to have some specific numbers within your software. You can also have the police numbers, you can have the fire department number, you can have the ambulance number feed in within the system. It is going to call the police department within a case of emergency. If suppose within the fire, if you've got the fire sensors, if suppose the fire has been lit up within your house, then it is going to call the fire department. You need to feed in the numbers. Here it is going to inform the fire department as well as the home owner. Then the last point is activates, deactivates the security system. That is, if you want to completely activate or deactivate the system, that task can also be performed. So these are the different ways in which the homeowner is interacting with the system. These are the different ways. Now, Cockburn suggests the following template for detailed description of use case. Now, the person, Alistair Cockburn, this was the person that assigned the crystal agile model. Now, this same person in here, he has suggested a template for the detailed description of use case. That is a template that you're going to follow. Within that, the first is going to be use case. What use case you're developing? This is initiate the monitoring. That is, you want to monitor the safe home security system. The primary actor, who is the primary actor? You're going to identify the homeowner. What is the goal of this? To set up the system to monitor sensors when the homeowner leaves the house or remains inside. This is the goal. The homeowner wants to protect his house when he is staying within the house or moving out of the house. That is the goal. Preconditions. Now, within the preconditions, you're going to have a password. If that password is correct, then you can change any settings within the sensors, whether you want to activate or deactivate the sensors. If you know the password, then only it can be done. The next is triggers. Now, what are triggers? The homeowner decides to set the system, that is to turn on the alarm function. Now, when you've turned on the alarm function means when you've activated the system, when you've activated the sensors, that is a trigger. That is, when you've activated the sensors, it means your safe home security system, it is armed now. Then the next is scenario. Now, what is a scenario? Now, within this scenario, the homeowner is going to observe the control panel. The homeowner will observe the control panel. Now, within this control panel, he's going to enter the password. That is a scenario. That is what is happening. You're narrating that. Then the homeowner, he can either select the stay function or the away function. Then after that, he is going to observe the alarm light. Now the alarm light means the sensors are activated. It means that the safe home security system, that is the control panel, it is armed now. So that is the scenario. You're going to narrate the entire scenario for the actor, that is the homeowner. So this is the scenario, the story. Now the next part is exceptions. Now what are exceptions? Now exception, within the exception, if suppose the control panel is not ready. Now the control panel is not ready means the specific door or window is not closed. You need to close them. That is one exception. How when the control panel cannot be ready, it means that some specific sensors are not activated because the door or window is not closed. The second exception is that the password can be incorrect. Now when the password is incorrect, it means that you are going to either re-enter the password. Now if suppose the password, it is not recognized, that is you're entering the password but it is telling you that it is not the correct password, then you can reprogram the password, put in the new password. Then another exception, it can be whether you've selected the stay function. Stay function means all perimeter sensors are activated, that is outside the house all your sensors are going to be active. If you're selecting the away function means when you're leaving the house, means in here all sensors will be activated. So this is the first part, that is the exceptions. The next is priority. Now what is going to happen within priority? Now priority is the frequency of use, that is how many times will the safe home security system will be used. It is going to be used many times within a day. Whenever you're entering or leaving the house, that many times it will be used. Channel to actor means how this actor is going to interact with this control panel, that is via the control panel interface. He is going to make changes, he's going to enter the password and he can make changes within the sensors. That is how he is interacting with the system. He's entering the password, then he can make changes within the sensors, that is the stay function, away function, that all can be identified. Then the secondary actors, what can be the secondary actors within the safe home security system? Now within the safe home security system, you can have technicians and sensors. Within sensors, we have already learned sensors that can be your door or window sensors, can be fire sensors, different types of sensors that you are attaching within the home. Those are the different sensors. Whereas the technician is who is going to maintain this particular software. He is the technician. If anything goes wrong with the software, who are you going to contact? And then the next one is channels to secondary actors. Now how you're going to interact with the secondary actor? Support technician via the phone line, that is you can contact the technician via making a call. And sensors are hardwired and radio frequency interfaces. You can have some remote functionalities that can be used to open the door, close the lights. This all can be done by the sensors. The next are open issues. Now what are the different open issues? Now open issues means, now there are 3 to 4 different open issues. Whether there is another way where you can activate the system without entering the password. If there is a way or not, you're going to identify that. If additional text messages can be displayed on the control panel or not, that is going to be identified. Now, when you're making the use case, you need to identify all the different issues. If there is another way to activate the safe home security system without the password, it means you need to embed that particular feature within the system. That is, if you can activate the system via your PC or your mobile, then this control panel that you're designing, it should be compatible with your PC and with your mobile. Now, if it can show additional text messages, then you need to have the display a bit wide, and how the messages are going to be displayed, how it is going to store the messages that need to be displayed. That function need to be embedded within the software. Then the next is how much time will the homeowner have to enter the password after the first key is pressed. That is, suppose it is a 4-digit password like 3214, something like that. If he's entering the first key 3, within how many seconds he need to enter the entire password, that does need to be identified. Some specific time is allotted for entering the password, or there is no specific time, that does need to be identified. Now this is identified so that you can secure your home. That if another person is making use of different combinations and that, so that you can identify. Now, as within the first step, you have identified if there is another way to activate the system without the password, you are also going to identify whether there is another way to deactivate the system before it activates. So these are the different open issues. This is the template for designing the use cases. Now, whenever you're designing the use cases, you're either going to make use of one use case. Now, one use case is going to give you only the functionality of the system, whereas if you make use of different use cases, it is going to depict the entire functionality of the system. Now we'll see the use case diagram for the safe home security function. Now we're drawing the use case diagram for safe home security function. We'll be having, first we'll be adding the system boundary. I'll extend system boundary, then add a few use cases. We'll first draw the use cases, then we'll enter the text. Five different use cases. You're going to have your homeowner, then another actor as the system administration, then we'll have all the sensors. Now we'll write all the use cases. Arm or disarm the system, that is, you are activating or deactivating the system. Then the next is access the system via the internet, that is, you can make use of your personal computer or your mobile to make changes within the software. Then next use case will be respond to alarm events. That is, in case of fire, when the alarm rings, what is the response that you're going to take? That is, the water sensors are going to be activated and a call to the fire department will be made. Then encounter an error condition. Now, whenever you activate an error within the software, that is your password is not matching or your sensors are not working according, then the next one is the last one, reconfigure the sensors and the related system features and the system features. So these are all the 5 different use cases. Now the next task is will draw the relationships. The relationship will be the first homeowner is responsible for arming or disarming the system. That is direct relationship. Then the homeowner can access the system via the internet by making use of his computer. Then this homeowner is going to respond to an alarm event, that is a message is going to be sent to the homeowner, as well as you've got an additional functionality that you can have the call made to the fire department also. Then this homeowner can also identify an error within the system, that is if suppose a password is not recognizable, then at that time he's going to make a call to the technician. The technician is your system administration. So this system administrator, he is responsible for reconfiguring the system and the sensors and the system related features. That is if any error is there within the safe home security system or within the sensors, whether the sensors are not detected by a safe home security system, then the system administrator, he needs to again reconfigure all these system sensors within the safe home security system. Now this homeowner, as he's responding to the alarm event, this sensor is also going to respond to the alarm event. That is if suppose there is a fire within your home, so this fire is going to be identified by smoke sensors, and then water sensors can be activated. Then encounter an error condition, that is if suppose a sensor is unable to sense a particular event. Sorry, I'll just write another. It encounters an error condition that is also detected by the sensor. Then when the system administrator is reconfiguring all the sensor and the system features, then he need to access the sensor. That is the sensor needs to be connected again to the safe home security system. So this is the use case diagram. That has how you're going to design a use case diagram. You're going to identify the different scenarios. Based upon those scenarios, you're going to make the use case diagram. That is, you're going to have actors, you're going to have system boundary, you're going to have use cases, and you're going to have relationships. 4 things are there within a use case diagram. Now within 2 marks also, the use case diagram can be asked, define a use case diagram and to give a example. So you can define the use case diagram, that it is a behavioral diagram. It depicts the behavior of the system. Now what type of behavior means? It depicts the dynamic behavior. When dynamic means while the system is running. There are 4 different elements within the use case diagram. You can label the elements, that is actor represented by a stickman, rough you can draw. Second is system boundary, draw a rectangle. Third, use case, you can draw this ellipse structure. Then relationship, those are arrows. You can have an association, you can have generalization, different relationships are there. You can have an include relationship, you can have an extend relationship. These all relationships we are going to see within the lab. So you can draw that. If it asks an example, then you can give a small example for opening an account where a homeowner, within the same example that I've given within the first. So this is the end of today's class. Thank you.